Welcome to module 37 of database management systems. We have been discussing about database recovery. This is the second and concluding part of the database recovery. We have earlier discussed about failure classification, storage structures and significantly the log based recovery mechanism. In this we will focus on concurrent transactions and understand the recovery algorithm for them, and we will understand the operation of logging for recovery. With early lock release, we will learn about another kind of logging mechanism. So, the recovery algorithm. So, what we have seen so far are we have learned the basic concept of recovery and logging, and we have assumed the serial execution of transactions, and now we discuss the concurrency control issues. So, now we will assume that there are multiple transactions operating at the same time and the components that are required for the recovery of those. So, with concurrent transaction, all transactions share, we already know that every transaction has a private work area, that assumption stays, but we talked about a system buffer area. So, that system buffer area, the area would be common for all different transactions. Also, the log area would be common for all transactions. So, now the in the buffer area, the data writes are or reads or writes are done for different transactions, and in the log the different logs of different transactions are mixed up. So, we make one assumption that if a transaction has modified an item, then no other transaction can modify that same item unless that transaction is committed or aborted. So, which means that kind of when the transaction modifies the item, it holds a lock, and that lock is held till the end of the transaction. And this is the, I mean, if we think back in terms of our locking protocol, this is the strict locking protocol that we are talking of. This is important for recovery, because if we did not have this, then it is possible that multiple updates to the same data item are done by multiple transactions. So, if we have to undo that, then we will not know which one to be undone with. So, that is a basic problem. So, we will assume an exclusive lock in this case, and log records will be written interspersed as we have already. So, in terms of our storage access mechanism, the same earlier diagram. This is, here is a disk, here is a buffer, the buffer is common and the private work area. So, now in addition to T1, we have another transaction T2 with its own buffer area, but so the x has been written in T1, has been read in T1 as x1, x has also been read in T2 as x2, and each are concurrently making changes in that private work area, but they are using the same system buffer area for writing the output back to the disk or reading directly from the disk. So, this is the model that we will go with. So, what is the recovery algorithm? First is logging, and the logging structure remains same, the start transaction log, the update transaction log and the commit transaction log as before. When you have to do a transaction rollback during normal operation, so for that transaction Ti to be rolled back, what we will need to do? It is a rollback, so undo has to happen. So, we will scan the log backwards from the end, and for each log record, update log record, we will restore the original value from which was written over, and we will write a compensation log record as before. And going backwards in this way, when we come across the start log record, then we will stop the scan and write a abort log record in that place. So, it is exactly same to what we did. So, now let us look into the actual recovery algorithm. So, the transaction rollback has no difference. So, in the recovery algorithm, what we do, we have a recovery phase, and where we replay updates of all transactions. So, we make sure that all transactions, whatever they did, those are done again. So, after the failure, we recover from the failure. So, we do all that again, whether they had committed, whether they are aborted, whether they are incomplete in every case. And then we keep track of what are the transactions which did not complete, and for them we do an undo phase. So, here I am showing another example here. So, this is the last checkpoint where all updates, I mean freezing the updates, everything was output to the disk, the log as well as the data item updates were put to the disk, and the set of transactions that are live during that time, well execution in that time were recorded. So, if we look at that set L in this case, then it will be T2, T3, these two transactions. So, we can we have already seen that our strategy would be that we will ignore T1 because it had completed before the last checkpoint. T2 and T3 were ongoing, and then T4 has started after checkpoint and committed before that. T5 started after checkpoint, but was also active, was also in execution when system failed. So, our strategy would be that we will assume as if this whole thing is redone. So, T2, T3, T4, T5, all these log records exist. So, we will follow through them and redo all of them. If we redo all of them, then naturally we come across T3 and T5, which cannot proceed further because the system could not proceed further, because so we do not know in terms of the log what would have happened to them because the system had failed. So, after having done this, then we do an undo phase where we undo this, but naturally the effect of these will remain. Now, you can question that this could have been done in a more smart way. Do we really need to redo everything and then undo some parts of that? That is a overhead in terms of that, which is true, but this just makes the whole algorithm simple and the overhead actually is not very high. So, what will you do in the redo phase? In the redo phase, you will find the checkpoint and you will scan forward from the checkpoint record, and as you scan forward from the checkpoint record, if you have an update, you will simply redo, which means V2 will again be written to xj, and when you find a start transaction, then you do not know, just look at this point carefully. If you find a start transaction, for example, when you are working on this, suppose you come across a start transaction here, you will come across a start transaction start here. So, whenever you get that, then you put this into the undo list. Initially your undo list is L, because they were going on. So, you do not know whether they could finish or they still need to be undone. And when you come across a new start, you add that to the undo list, and the rest of it is simple. So, you keep on going this way. If you find that the commit has happened or abort has happened, you remove that from the undo list. But if you do not find that, then that stays in the undo list. So, you know if you proceed from in this direction in the redo phase, you know at that when you have scanned the whole log, you know what are the transactions which still need to be undone. So, that is a simple strategy that is followed. So, whenever you have a log record start, then you put it to the undo list, and whenever you get a log record which is commit or abort, which says that before the system failure, the transaction actually had either committed, that it finished everything, or had to roll back, then you remove that from the undo list. So, what will be left out at the end will be the undo list of transactions that need to be undone subsequently in the undo phase. In the undo phase, you go backwards because it is undo. So, what you will do is very similar. So, if you have an update record, then you undo in the transaction which is in undo list, then you do exactly in terms of transaction rollback, that you write the old value and write a redo only log record. Now, when you find going backwards, when you find TI start, so you know that this is the starting point of the transaction and the transaction is in undo list. So, it came across because it could not be it was on the undo list. So, which means that it could not be completed, and therefore, you have found the start. So, this is where your undo operation is over. So, you write a abort log record, and once you have written that, then you are done with the transaction. So, you remove that from the undo list, and in this way you will continue till your undo list is becomes empty. So, once it becomes empty, so then you have found the TI start for all transactions in the undo list, and there is nothing more to do. So, After undo phase completes, normal transaction processing can commence. So, your failure recovery from the failure is already taken care of. So, here are certain examples which you could check at. Here is a start. So, this is this is the order in which the transactions are going, and this is the crash point. This is where it failed, and mind you, so this is where, and this is where our checkpoint is. So, at checkpoint you can see that T 0 and T 1 are what are your candidates. So, when you start in the redo phase, you start from this point, because before that everything has been done. You naturally you come across this. So, you redo this, which means you again actually change C from its old value 700 to 600, and then T 1 commits. As T 1 commits, you know that this transaction is done with. So, you remove that. So, your undo list at the beginning is T 0 T 1, but going in the forward direction, when you come across T 1 commit, you naturally remove that from your undo list. Then you come across T 2 start. So, you know that another transaction is starting now. So, it may be you do not know whether it could complete or you could not. So, you add that to the undo list, then give effect to this update. Then for T 0 we have you have a rollback record, that is because T 0 actually you can see that T 0 has aborted. So, the change that T 0 had done earlier, this had to be rolled back. This rollback is a normal transaction rollback, this is not because of the failure. So, this rollback had happened, and this is where the rollback is complete. So, T 0 is also completed. So, T 0 after this is taken care of, then in the redo phase T 0 is also complete, and this is where you reach the crash point. So, your undo list is left with only T 2. So, now when you have done this, so when you have taken done the redo here, that is this T 2 which is ongoing is there, then you will write this log record. So, these log records are written during recovery, not during the original transaction, and T 2 had to abort because of the system failure. So, T 0's abort was due to the transaction rollback, but T 2's abort is because of the system failure. So, T 2 is rolled back in the can be rolled back in the undo phase. So, once this has been done, then you do the undo phase starting with T 2, and then you go backwards. As you go backwards here, so you will undo this. This is what you write. You come across T 2, and naturally you have rolled back. So, you write T 2 abort. This is how the actual rollback can happen, and you can see that now with this redo undo phase, you can always bring back the database to a consistent state, and these transactions are executing concurrently, and therefore, your log record is a intermix of the log record of different transactions. Now, the last that we would like to talk about is recovery with early lock release. What this means is, well, so far we have talked about recovery which is only in terms of data update, single data update. So, I mean, if I want to recover, I can just write back the old data, but this is not true in case of many other situations. For example, if you are inserting a record in a B tree, then it is not enough only to undo that, because you cannot undo and get back the same. As you can understand that if you make inserts or deletes in the B tree, if you have made an insert, then the structure of the B tree itself has changed, and after that several other inserts, deletes may have happened. So, if you now want to just go back and undo this particular insert in terms of values, it is not possible to do that. So, when you want to do that, so you cannot do really kind of repeating the history kind of strategy. So, what you have to do is do some kind of an undo which is logical. So far the undo was physical, that you wrote this, you change this value by this value. So, your undo is a physical. So, you restore the original value and your undo is done. Here it is logical, that is for the operation that you have performed, you try to find out a matching operation which creates the similar effect as of undo. So, if you have inserted, then your undo is a corresponding delete of that record. If you have incremented by 10, then you can say that your corresponding undo is a decrement by 10. So, that is what is known as the logical undo, and its logical undo is a very good option in case of delete of insert or delete of tuple. So, if you have deleted a tuple, undo to insert, if you have subtracted, then undo to undo deposit to go forward and so on. So, a redo information is logged physically. So, new values for each write, even for operations which are logically, which has logical undo. So, you do not do a logical redo. I will not go into the details of why this is not done, but it simply makes things very complicated. So, physical redo is always physical, and you can show that physical redo does not prohibit this kind of operations that we are trying to do, but the logical redo is not used. We will only use logical undo operation. So, how do you log for such a logical undo operation? What you do is, instead of now it is an operation, it may not be a single value update. So, it is not captured in terms of one log record, but it could be a number of log records which have actually done 3-4 different changes to make that operation happen, and you want to actually define an undo for that operation. So, when you start this, so you start with a log which says that what is the transaction and what is the operation. So, you put an identifier to the operation and then you write operation begin. So, you know this is where operation has started. Then all the things that are happening for this operation while the operation is executing, then you write normal log records with physical redo, physical information, all these logs are written. And when this operation ends, mind you, this is a particular operation you are talking of. So, not the whole transaction will continue. When that particular operation ends, then you write an operation end record, and along with that you write what is a logical undo information, you put that in. So, let us have a look at the example. So, suppose your operation is insert of a key record pair. So, let us say this is the key record pair and into index I9. So, this the operation starts here, and then there are several steps to be done. For example, you will have to say if x is on the key value which at 10 and is becoming K5, you will have a physical update undo record of this. If y is the record ID which is RID 7, then y changes from 45 to. So, these are all physical redo steps in insert. So, these are the different instructions in terms of this broad operation, and when you are done with all that, then your operation ends and you write this undo information. So, insert of, so you had insert of this record with index 9. So, now you do write your, what will be the undo? To delete that from index I9, to delete this key record ID pair. So, this is the whole logging that we do. So, you can make use of this undo operation in terms of your recovery process. So, if the crash or rollback occurs before the operation completes, then operation end log record is not found, you will not find it. So, you do not know what is the undo operation. So, in that case the physical undo information will be used to undo. But if we have a crash or rollback that happens after an operation completes, then the operation end log will be available, and in this case we will use the undo operation that is given in the operation end log record and do a logical undo, and we will ignore all the physical undo information that the operation that we will find in the log records. Redo, of course, will still use the physical redo information which is there. So, if we look into the actual if we look into the transaction rollback with logical undo. So, if I have a update record which is naturally physical, and then we can perform the undo, which is as we did last time, the creating a redo only record. If I find an operation end record, then to roll back we will pick up the logical undo information from you, and we will perform that operation. At the end of that we will certainly write the operation abort record to mark that this operation has been aborted. So, if we have a redo only record, then we will ignore it, and if we find an operation abort, then we will skip all the records that were found till the beginning. Naturally, you can understand that 3 and 4 will not happen in a normal course of transaction. It will happen only when the failures have happened during recovery, and at the end we will add a TI abort record to the log. So, the critical thing to remember in this, that whenever we are doing operation unlogging, we are doing undoing based on the operation logging, then since once we get the operation end, since we know what the undo information is, we have to make sure that through the undo process we actually ignore the physical undo records that exist in the log, and just go with the operation case. So, these are the notes that I just mentioned. Okay. So, this is an example which you will have to spend some time and understand with care. So, you can see that a transaction T0 has started. This is where it has done a physical update, is a physical undo record, and then it does an operation. Of course, it is a simple operation which changes the value of C from 700 to 600. So, naturally, so it has decremented by 100. So, your undo operation here is incrementing by 100. So, if T0 aborts here, if T0 aborts somewhere here, before your operation end has happened, then naturally the undo will have to be based on this physical undo structure. So, you will have to replace 600 by 700. But if it happens after this, then this is the case. If it is completed the operation and then the failure happens, then you will do the logical undo, that is whatever the value of C is, you will just logically add 100 to that. But that means that when you go backwards from here to find the begin, you will actually have to ignore this physical undo record, because you have already given effect to that in terms of the operation undo that you are doing. So, this is the basic difference. Here are different subsequent examples on that, and you can see that well, here after the operation end has happened, then possibly it has released the T0 has released the lock on C1. So, T1 has again taken the lock, T1 has again done the updates. So, then it releases that, and T0 at this point might decide to abort. If T0 aborts, then this logical undo of O1, this operation will add, it had to add 100. So, it adds, now this C had become 400, now it is adding 100 back. So, C becomes 500, and then the operation is finished. So, you write operation abort, and O1 undo of O1 gets completed, but you still have, after going backwards in this, you still have this record which was directly updated. So, these are the undo transactions, undo log record for that, where B is being restored from 2050 to 2000, and you record the transaction abort for T0, T1 eventually has committed here. So, this is how the transaction rollback will happen when logical undo is also used, and this is a very powerful way to take care of that. This is similarly another illustration for doing the failure recovery for with logical undo. So, here is the undo is a redo phase that you are seeing here. This is where the end of log at the crash. This is a redo phase because this is a checkpoint where T1 was there. So, at the end of redo T1, if you so you are starting to redo from here. So, you have done operation end, T1 has not finished, T2 has started. So, you have added T2 to the undo list, and when the crash has happened, both of them are on the undo list. So, they have to go through the undo pass. So, we undo T2 C 400. So, this is what this is how you will go. So, this is the first thing you undo, and then naturally you have come to the beginning of T2 start. So, you abort, and you are going back again, and you are trying to do this. Why are you doing this? Because when you go back to undo from this point, you come across this operation end, which tells you that the undo operation has to happen by incrementing C by 300. So, C which had become 400 is now incremented by 300. You come to the checkpoint, which is the end here in terms of the operation begin, and naturally you declare operation abort. And going back further, this is what you had when transaction T1 had started. So, you undo that, that is again a physical undo, and finally T1 aborts. So, this is how in both cases of transaction rollback as well as in terms of the failure, the recovery can be done with the logical undo process. Here I have given another example. I will not go through it step by step. So, what I urge that you go through that following the same logic and convince yourself that you understand that how this transaction rollbacks with physical undo as well as logical undo is taking place. So, with this the recovery algorithm with logical undo will look very similar to what we have already done with the physical undo redo, and that is what we have stated here. There is nothing significantly new. So, I expect that you should be able to go through these steps, and those will be clear to you. Again, we have a two phase recovery of redo phase and the undo phase, and we make use of the operation undo, logical undo as and when it is possible, and when that is, and when we do that, we ignore all physical undo records, and when it is not possible, then we will use the physical undo records, and that is how the recovery can be achieved. So, in this module we have exposed ourselves with the recovery algorithms now for concurrent transactions as well, and we have shown that how recovery can be done using operational logging, operations logging, and making sure that really the database may not need to hold on to a lock for a long time on the data item and delay other transactions, but if it can define the undo operation on the data item, then it can release that lock early and use that logging mechanism, operation logging mechanism to recover the data.